guys, welcome to Space Talks, and today we're going to be talking about black holes. So let's get started. So what are these mysterious mind-boggling objects? Well, let's get into it. Now, black holes are some of the strangest and most fascinating objects in outer space. They're extremely dense with such strong gravitational attraction that even light cannot escape their grasp if it comes near enough. But who brought up this topic of black holes? And of course, it was Albert Einstein. He first predicted the existence of black holes in 1916 with his general theory of relativity. And the term black hole was coined many years later, in 1967 by American astronomer John Wheeler. After decades of black holes being known only as theoretical objects, the first physical black hole ever discovered was spotted in 1971. And here is what the first picture of a black hole looked like. It's not much, of course, a little blurry, and we can't exactly see the details. But for that time, it was a great development, as we finally had proof that black holes actually existed. And most black holes, they usually formed from the remnants of a large star that died in a supernova explosion. Just as a brief explanation, a supernova is a large explosion that takes place at the end of a star's life cycle. It is the largest explosion that takes place in space. Others are formed by merging into each other or with two or more black holes. Now we're going to be talking about types of black holes. So the first one is stellar black holes or stellar mass black holes. Now, stellar mass black holes are usually categorized in terms of what they're made of and their formation. They're born when extremely massive stars collapse, and they typically weigh between 5 and 10 times the mass of the sun. Now we're going to talk about supermassive black holes. A supermassive black hole is the largest type of black hole with mass on the order of millions to billions of times the mass of the sun. A Hubble census of galaxies showed that supermassive black holes are commonly found in a galaxy center. So as you can see, this is a galaxy here, and in the middle, that is the supermassive black hole. Excuse me. So now we'll be coming to intermediate black holes or intermediate mass black holes. Now, an intermediate mass black hole is a class of black hole with mass in the range to 10 to 2, for example, 10 into 2, to 10 to 5 solar masses. That basically means the mass of the sun used as a unit of mass. And this is significantly more than stellar black holes, but less than 10 to 5 to 10 to 9 solar mass supermassive black holes. And now we come to miniature black holes. Now, these are like stellar or supermassive black holes, but only much smaller, and they have less mass comparatively. A miniature black hole found some 2 to 3 months ago, called the unicorn, lies a mere 1,500 light years from us, and it may be the closest known black hole. And it's just 3 times more massive than the sun. So that's how tiny a black hole can be. And this unicorn is quite surprising. And now we will talk about a black hole called Sagittarius A, which is believed to be at the galactic center of our galaxy. And during it, we will cover some basic information, and this might relate to other black holes in many ways. So, at the very heart of the Milky Way, there is a region that is known to be the home of the supermassive black hole, with millions of times the mass of our own sun. And with the discovery of this object, astronomers have turned up evidence that there are supermassive black holes at the center of most spiral and elliptical galaxies. So this is a little photo of where Sagittarius A might be located. So, how was it discovered? So, infrared observations of stars orbiting the position of Sagittarius A demonstrate the presence of a black hole with a mass equivalent to billions of suns. For these infrared observations, American astronomer Andrea Ghez and German astronomer Reinhard Genzel were awarded the 2020 Nobel Prize for Physics. Now we're going to just do some quick facts on Sagittarius A. So it's also known as SGR A, and don't forget the star, because there is a Sagittarius A without this star that is actually a star. So if we don't include this, then we could confuse it. And next is the distance from the Earth. That's about 26,000 or 25,640 light years to be exact. And it's 4.6 million times the size of the sun. So that's a lot. And it's a supermassive black hole, and it's located in the Sagittarius constellation, and the location in the galaxy is the galactic center. So now we're going to be talking about how was it found. So as late as the 1990s, it was theorized that a supermassive black hole was at the center of the Milky Way, but it was unproven, so we're not sure if it was even there. So as you can see here, there's early observations of stars, and hereabout is the center of our Milky Way galaxy. And this is by 1998. Now when we come to 2000 to find evidence, astronomers begin by observing the Milky Way center regularly, identifying individual stars and their orbits. So we've now found new star locations. And by 2003, as the stars' orbits became more defined and clearer, researchers began theorizing about the Milky Way center. What do the stars point to? As you can see, they're all pointing here, while this one is off track, right? Yeah, so researchers determined that something 4 million times the mass of the sun is inside these orbits by 2006. So you can see these orbits, they're 16 years. For 16 years they've been verified. But this one is undetermined because it's pointing somewhere else while these are pointing in a different direction. So it kind of looks like it's being pulled at. And in 2009, the star's orbits provide overwhelming evidence of a supermassive black hole at the center of our galaxy. So now the supermassive black hole is confirmed. And so we're going to move on now. So telescopes of all types are used to see distant objects. The larger the diameter or aperture of the telescope, the greater its ability to gather more light and the higher its resolution or ability to image fine details. To see details in objects that are so far away and appear small and dim from Earth, we need to gather as much as light possible with very high resolution, so we need to use a telescope with a large aperture. So to picture black holes, we would need a telescope as huge as the Earth. And yeah, that is so huge, but we can do that. So in this case, we use the Event Horizon Telescope to picture black holes and other mysterious distant objects. And as I explained, there are many telescopes around the world which together when combined makes the Event Horizon Telescope. And then we use the VLBI method to picture black holes. That's why the VLBI technique was so essential to capturing the black hole image. VLBI works by creating an array of smaller telescopes that can be synchronized to focus on the same object, same time, and act as a giant virtual telescope. So they get data from here, and all the places around the world, combine it, and get the image. And this technique has been used to track spacecraft and to image distant things in space and more. So this is a little how one of the telescopes looked like. It's a part of the Event Horizon Telescope. And now we're going to be watching a video of the location of the Event Horizon Telescope collaboration. So yeah. So this one's in Spain. The other one was in Antarctica. And now Chile, another Chile, Mexico, Arizona in USA, Hawaii in USA, and another in Hawaii in USA, and Antarctica. And then Spain again. So this was the collaboration of, and now we will be doing a Q&A session in which a few questions by people on this topic will be answered. So the first question is, will our sun become a black hole? So you can write your thoughts in the comment section too. And here's the answer. So it is no. It's too small for that. The sun would need to be about 20 times more massive to end its life as a black hole. And even if it was able to be a black hole at this size, its mass would be too little, and so its gravitational pull, so it wouldn't affect planets, except for making them darker and colder. And in turn, that would affect life on Earth, but yeah. So let's go to the next one. Now, what is the event horizon? Now, this is a very, very, very important question in the topic of black holes. So, the event horizon is the boundary defining the region of space around a black hole. So, basically, it's a boundary around the black hole and from which nothing, not even light, can escape. So, you could cross the boundary, like go in, but you can go in, but you can never, ever come out. So that was a big one. Now, what is a quasar? Quasars live only in galaxies with supermassive black holes that contain billions of times the mass of the sun, as we know. Although light cannot escape from black holes itself, some signals can break free around its edges. So here's the event horizon. Around it, there are some signals that break free. And since they haven't crossed the event horizon, they aren't sucked in. So, while some dust and gas fall into the black hole, other particles are accelerated away from it and near the speed of light. The particles stream away from the black hole in jets above and below it, transported by one of the most powerful particle accelerators in the universe. And these are now quasars. So as you can see, this blue kind of light escaping from the black hole, that's when a quasar is. And now the last question is, what are primordial black holes? Primordial black holes are thought to have formed in the early universe soon after the Big Bang. And these black holes are a hypothetical black hole. Know what I mean? So you might be thinking that, why didn't we talk about this? Because you might think it's a type, right? Yeah, we haven't because they're hypothetical. And some people say it should be a type. but it isn't considered a type because there is not much evidence to state it as a type. And as we talked about, it is a hypothetical kind, so scientists aren't sure. Okay, so thank you for watching, and here is the link to the Event Horizon Telescope video. I will be sure to post that.